My name is Trisha Morris, and I would like to welcome you to my channel, Mathematics Simplex, where you will be able to view videos you might find difficult in your class. Please don't forget to like this video and subscribe to my channel. Today we'll be doing the inverse Laplace transform, where we're finding inverse of a function of s to give us a function of t. Now finding the inverse is just moving in the reverse. I've done a video on finding the Laplace transform of a function of t, and we're moving to the function of s. But today we'll be moving in the reverse direction, where we're moving from an s function to a t function. So say, for example, I have this function, 3s plus 4 over s squared plus 9. Now, looking at this, we have a fraction form that we can split. So if I forget about this 4, we'll have 3s over s squared plus 9. And if I forget about this 3s, then I'll have 4 over s squared plus 9. Now we're finding the inverse. So we look at the first fraction and factor out the 3. So we have s over s squared plus 9. And the next function now, we have something that is happening. So what I'm going to do, I'm going to display my whiteboard and explain what is happening. So just to remind you, the Laplace transform of sine AT is equal to a over s squared plus a squared. So we're moving in the reverse. We're moving from the s function to get the t function. So that what we have is 4 over s squared plus 9. First, we can identify that a is 3 because 9 is a perfect square. 9 is the same thing as 3 squared. So that gives me that my a is 3. So I can rewrite this as 4 over s squared plus 3 squared. Now we can't just say that this is sine AT because the formula says we have to have a in the numerator, which is 3. So if you look at this, I don't have a, but we can balance this where if I put a 3 in the numerator because we want the 3 there, because we want the formula, but we also can't change the value. So that means I would have to multiply this by a third, which is balance it out. So 3 times a third is 1, and 1 times 4 is 4, so I'm still having 4 here. Then what we can do, the only value we want is a number 3 in the numerator. So let's put this in the brackets. So I am going to factor out the 4 and the 1/3. So factoring it out, I'll have 3 in the numerator, and then I'll have s squared plus 3 squared. So remember, we're trying to get a over s squared plus a squared, and that is what I have here. A, which is 3 over s squared plus 3 squared, and we can say 4 times a third is 4 over 3, and this is 3 over s squared plus 3 squared, close bracket. So this is 4 times a third, which is 4 over 3, and this is 3 over s squared plus 3 squared. And as you can see, this is my sine AT. So let's go back to my slide. So that's what I have here, guys. 4, we change it so that it becomes 3 times 1/3, that's still 1. So it's still having the 4 in the numerator. Now, when we find the inverse of s over s squared plus 9, we will be getting cos 3t because 9 is the same thing as 3 squared. And the cos function, cos AT, is s over s squared plus 3 squared, which is a squared. So a is 3, so this is cos 3t. 4 times a third, that's 4 over 3. And the inverse of this is sine 3t, because we established that 9 is 3 squared and a is 3. And that is the function of t. So let us do another activity. Find the inverse of 9s minus 8 over s squared minus 2s. Now with this activity, s squared minus 2s is the same thing as s times s minus 2. So we can apply partial fraction where I split it as two fractions where it's a over s plus b over s minus 2. And all I'm saying, we have s squared minus 2s. I can rewrite this as factor of the s. So we have s minus 2. So when we split it using partial fraction, it will be a over s plus b over s minus 2. Now we're going to find the LCM. So the LCM will be s times s minus 2, where you have s into the denominator, so the s cancels. So we have s minus 2. Then you'll have s minus 2 times a to give you a times s minus 2 plus this s minus 2 into denominator, this cancels, so I'm left with s, and b times s to give you bs. Here we have the numerator. We are going to use a trial and error method where we substitute values of s to make one side be 0 and the other side we have a value so that we can solve for the unknown, which is a or b. So in other words, let s be 0. It means if I put a 0 right here, the 0 times b cancels, so this is gone. So what I have is 0, 9 times 0 is 0, minus 8 to give you negative 8, and 0 minus 2, that's a negative 2, and when I replace 0 here, that's gone. So it means that a is 4 when we divide both sides by negative 2, we'll arrive at this answer. Now if you look at this, we can say, okay, which other value of s can I substitute into this equation to eliminate one of the letters, which is s to be 2. So substituting 2 into the function, we have 2 times 9 minus 8, and then here we substitute 2, so this will be gone because 2 minus 2 is 0, 0 times a is 0, and then substitute 2 here, so we'll have b2 or 2b. Now 2 9s 18 minus 8, that's 10. Then we divide both sides by 2, so now we have b to be 5 and a to be 4. Therefore, 9s minus 8 over s squared minus 2s as a partial fraction is 4 over s plus 5 over s minus 2. Now, let's not forget, we haven't found the inverse. We just express it as two fractions, but now we're able to find the inverse of 4 over s and 5 over s minus 2. So rewriting 4 over s as 4 times 1 over s plus 5 times 1 over s minus 2. Now we said that the Laplace transform of 1 is 1 over s, and the Laplace transform of e to the at is 1 over s minus a. So this 1 over s, it means that when I find the inverse of this, it will be 1. And when I find the inverse of this, what do you think it will be? E to the 2t. You're correct. So that means this will be 4 times 1 to give you 4, and this will be 5e to the 2t. And that's it.
Please don't forget to subscribe to my channel.